Well, the question is, a body is moved along a straight line by a machine delivering constant power. The distance moved by the body in time t proportional to, well, out of the 4 options, we need to find out the correct option. And it is a previous year question, 1984. So mainly our intention is to convert the power expression to the displacement equation of the distance equation of the, okay. So we know that power equal to what? Work done upon time only. So power is work done upon time. So work done is nothing but half mv square. It is change in kinetic energy, na? So we can directly write half mv square by t only, because initial energy will be constant. So either it will be 0 or it will be constant only. So here v is variable. So it means what I can write, you see, p is constant here, m is constant, only v and t are variable. No? So try to understand it, what I write here. So v square is equal 2p by m into t. Just if I crisscross it, na, p into t, that is p into t equal to half mv square. So v square equal to 2pt by m. So it means what? V is directly proportional to t to the power half. Because power is constant, m is constant. Say the constant of proportionality is, say, c, something c. Means instead of 2p by m, I am putting c. C is a constant. Now that v can be written as ds upon dt. Rate of change of speed, distance is equal to speed only. So ds equal to what? C t to the power half dt. If I integrate it, ds is small distance. So if I integrate, I get the total distance. It is equal to what? T to the power half plus 1 by half plus 1 only. So s equal to what? 2/3 of c, and that is t to the power what? 3 by 2. So again, this part is constant only. So it means distance is directly proportional to t to the power 3 upon 2. So out of the 4 options, I can see here the third option is correct.